In 1966, in the midst of a competition between the United States and the Soviet Union to determine which nation would dominate space, NASA was conducting experiments on the suits that astronauts would wear during space travel. And this nearly ended in a disaster. The American Space Agency wanted to mimic the conditions of space, and to do so, they created a vacuum chamber. It was an environment that had 3 large doors and could suck the air from inside, creating a vacuum similar to what exists in space. It was in this chamber that astronaut Jim LeBlanc entered with a prototype of a spacesuit. This suit was the only thing that protected the astronaut from the nearly absolute vacuum. But then, an unforeseen event occurred. Somehow, the hose that pressurized the spacesuit became disconnected. Thus, he discovered, in a rather unpleasant way, what happens to a human when suddenly placed in a depressurized environment. In an unbelievably short lapse of time, only 10 seconds, the suit he was wearing depressurized to the equivalent of just 0.6% of normal sea-level atmospheric pressure. Surprisingly, LeBlanc survived this accident without lasting consequences and reported that, before losing consciousness, he felt the saliva in his mouth beginning to bubble. The chamber he was in would typically take 30 minutes to regain its pressure, but with this accident, it was accomplished in just 87 seconds. But what would have happened if Jim LeBlanc hadn't been rescued in time? And if this had happened to someone in the vacuum of space, without wearing a spacesuit, could something even worse occur? Welcome to Futuristic Findings. My name is Robert, and in this video, I will show you what happens to the human body in space without a spacesuit. If pirates in the past used to force hostages to walk the plank and throw themselves into the sea as a death sentence, one day in the future, there may be space pirates. Traveling through the solar system in ships that do not adhere to interplanetary treaties, these space pirates could compel someone to hurl themselves into the vastness of space without a spacesuit, condemning hostages in the same way, which, let's admit, is a much more efficient way to die than simply jumping into the sea. After all, it takes only about 90 seconds for someone to die during exposure to the vacuum of space, which is the time I use to heat up my lunch in the microwave. And speaking of heating up, your body, without the protection of a special suit, would inevitably experience temperature variations. This is because we emit energy. And no, it's not positive or negative energy, but rather thermal energy. Normally, we lose and gain energy through the processes of convection and conduction, but in the vast void of space, there are no molecules to conduct thermal energy around you. So, the only other way to gain or lose energy is through radiation. Thus, in space, the main source of heat that could reach you would be the radiation from a star, such as the sun, for example. But this could cause another type of problem: extreme temperature variations. Imagine you were floating through space, and the sun was completely blocked by an object. There would be nothing to warm you, and your entire body would go through a gradual loss of energy. The energy you naturally lose through the slight radiation from your body. However, if the sun weren't blocked, and you were in a position where your belly was facing the sun, receiving radiation, only that part of your body would warm up. Your back, which would be facing the darkness of the vast void, wouldn't have any source of heat to warm it up, leaving you with a radioactive tan on only one side of your body. In space, the sun would have a much more damaging effect on your body because you would be directly exposed to high-energy photons, which could cause irreversible damage to DNA molecules. But all of this would take some time, so the first effects of exposure to the vacuum wouldn't be what you'd feel. In fact, you probably wouldn't remember much because you'd only have 15 seconds of consciousness left from the moment the exposure to the vacuum begins. Without the oxygen it needs to function, your brain would go into energy conservation mode, rendering you unconscious but still alive. So there would be a chance of survival if someone acts quickly, bringing you back to a pressurized environment with minimal harm to your body, but the rescue would have to happen within a tight window of opportunity. That's because if you spend more than 2 minutes floating lost in the vacuum of space, just like your brain, other organs in your body will fail due to the lack of oxygen, inevitably leading to your death. It's possible that in a hypothetical situation like that, where you're adrift in space without oxygen, your instinct might be to hold your breath in a desperate attempt to make the oxygen in your lungs last longer. But I'm sorry to say, that's a terrible idea. When you hold your breath in a vacuum, what happens is that inside your body, the air is trapped at atmospheric pressure, while outside your body, the pressure is virtually zero. So, due to this pressure difference, there's an extremely high tendency for the air in your lungs to rush out, and in a very violent manner. Holding your breath in these conditions can end up severely damaging your lung tissue, potentially causing permanent damage and even death. So, remember, the next time you find yourself in the vacuum of space without your astronaut suit, don't hold your breath. Your Monday will be much safer. And it's not just air that your body loses to the vacuum, but other fluids as well. Moist surfaces of the body, like the eyes and mouth, start to be affected almost immediately. The fluids in these areas start to evaporate, which was exactly the sensation described by Jim LeBlanc in the NASA experiment that didn't go as planned. And it's precisely the loss of these fluids that causes the most deadly symptom of exposure to the vacuum: embolism. Embolism is the formation of bubbles in bodily fluids due to the reduction in atmospheric pressure. This phenomenon begins to occur if you're in an environment with pressure equivalent to just 6% of normal sea level atmospheric pressure. In the vacuum, the nitrogen in your bloodstream begins to bubble, and these bubbles expand until you inflate to twice your size, becoming simply a human balloon. If not rescued in time, the effects of embolism can cause serious problems, such as damage to your organ tissues and even lead to death. The NASA experiment with Jim LeBlanc nearly ended in tragedy. This was just a small demonstration of how we, as humans, are fragile in the face of the universe that surrounds us. Sometimes we forget how the universe doesn't care about our existence. Outside the small, safe bubble that is planet Earth, the universe is almost entirely hostile to human life. And if humanity truly intends to expand to other planets and stars, we need to learn to respect the grandeur of the cosmos. If you're fascinated by these and other mysteries of the universe, subscribe to our channel, where we unravel the most intriguing questions about space and science. Take care, and until next time.